Hello all, I'm Yogam Priya presenting my second project, customer segmentation using K-means clustering at Infotact Solution. And this is my data set I used for my project. And then here, these are the columns we have ID, year, birth year, education, marital status, income, kid home, teen home, then customer, the purchase date, recency, and then these are the expenses made and accepted type, then compliance. Totally, we having 29 columns in our data set. So let's start processing it. These are required libraries in our data set. Just uploading my data set here. Just 5 rows. All the columns of my data set. Shape of data set, so 29 rows, 29 columns and 2240 rows. Info, that is it shows the data type of that each column. Then checking for any null values. No null values actually meta type, but a few blanks is are there. We just permit deleting it. Then checking now there is no blank or nor a null values in my data set. This data set or describe of statistical description. It shows count, mean, eight values. Then in education column we have some um, unique values count. Then marital status, these counts. Then we making a proper data type. Previously it was not proper, so we converting a date customer into date type format. Then we make checking it. Now that date customer is in date type format data type. Then we adding a few columns in our data type data set. There is no age column, so we making a age column. We having a date of birth of customer, so by using that we making age. So 2025 minus data set birth year. Then so this is will be the age. Same way we make doing a total children column by adding these two columns. Then all columns are here, and we also making all the spendings together in a list and adding these, summing it all and making up new column, total spending column, and it will be the one more new column. Then customer since column is also created. So today timestamp of today minus the data set customer date. So day, this is counting of days from their first day of purchase, then today. So customer since, so these are in number of days value. So let's start doing our graphical representation. So single variant graphs are used for his plot. So we using his plot here for doing age distribution and income distribution, total spending distribution, and then a box plot for education and income relationship to finding IQ or value, and education relationship between education and income. So this, by this we can easily find that the basic education will get the least income, and PhD graduation getting a more income value. And then we making one more box plot for marital status, total spending. So from this IQ average total spending can be seen. So here we can see alone can having a total spending, less total spending, and widow, single, divorce, they getting doing more spending. Then making a correlation for income, age, recency, total spending, number of verb purchase, number of store purchase. For this correlation, I'm making a correlation matrix for this. So from -1 to 1, making a correlation matrix. So red color will be the maximum. So 1, and then also we're making a pivot income for values like income, education, marital status. So all we're doing a mean, so taking an average for income. So here education is in rows and marital status in column, and making and doing an average income for this, taking inside properly, and heat map for this heat map for this in pivot income. Then we just grouping few categories like education, total spending, and their average, and as and arranging in larger to smaller values. Same way plotting for that. So here by doing this plot we can easily analyze that basic having basic education having total spending, less total spending, and also they are also having a less income also. Then same way acceptability, all these are making a into same, adding same list and adding it to a same column, making it to a single column. Here we see that accepted any having a five distinct values. So we're doing 0, that is lambda equal to 0 is equal to 0, greater than 0 as 1. So now we checking it, there is only two values, 1 and 0. And then we're also making a group for marital status and accepted any. So this will be the marital status and accepted any. And we're also making a plot for this. So by this we can analyze that say accepted rate, spending accepted rate, having upfront and YOLO having more, and then married and together having less accepted, compliance accepted rate. So we can easily take analyze from this, and we making a bin variant like 1830 for our graphical purpose, and also age we making 18, 19, 32, 39, 40 to 49, a range of age like this using for our graphical representation. So here this will be the age and this will be the values for that. Now we making a graph for bar graph here for income and age group. So these age group people earning this much average income for this age group people. At last, after adding few more columns in our data set, totally now we having 35 columns. So these are the columns, all the columns name. So now we can take the features from our data set: age, income, total spending, number of word purchase, number store purchase, number web visit monthly, and recency. These are the features we can take, and putting this into separate data set like X, storing it in X. And now we starting our data for pre-processing, SQL and pre-processing, standardizing our data set, so transforming and making a WCSS here, and then range 2 to 9. So now we getting values like this. We making a elbow plot here. So from this elbow plot we taking 6 clusters from this elbow plot. So these are 6 clusters, and we clustering it. So final cluster summary is this: finally we having 0, 1, 2, 3, 4, 5, totally 6 clusters are there: age, income, total spending, number of work purchase, number store purchase. These are the here values count, totally counts are here. So is finally I made a decomposition from our clusters using Streamlit library. So here a PCA data also taken, that is a component analysis. So this array is made. So PCA to data set, this data we got from this. Finally this is our final clustering for everything. So by this we can easily see customer 3 is having cluster 3 having more. So this is final summary of our cluster data. So job laboratory. Then this is our segmentation Python coding using Streamlit library. I imported now Streamlit library and joblib. So taking this, so these are the values, input values we're going to make here. I'm just running this. Let's run this. So now, so we can see, we can check our clusters, which cluster it belong to. So I add some web purchase like this, store purchase like this, monthly visit maybe 4, and last recent purchase date, let's take 18, and predict segment. So here it's showing it belong to predicted segment cluster 5. So frequent buyers they are. So by from this age group 39, income this much, total spending this much, and they do done web purchase this much, store purchase this much, number of visit per month, recency is 18. So that customer belongs to cluster 5, which means frequent buyers. This cluster has the highest number of purchases both online and in store. They have average income or average age. So this is my final output of my project. Thank you.